SwayamPrabha. Digital India. Educated India.
So, again I highlighted a few variables. Housing stock dynamics. Houses have an average, so completely different model. Imagine houses are built in a particular area. Housing stock have an average house lifetime of 100 years, after which they are demolished. The demolishing flow equals the number of houses divided by average house lifetime. So, if you imagine housing stock, so I highlighted all the stocks that is coming in, and the description itself uses the word stock. Probably you should model it as a stock, right. And demolishing means it has to be an outflow. All demolished houses are replaced. Initial houses are 5 million. Okay. Number of houses that are demolished per month enter a planned houses stock via a planning flow. So, what was demolished, I am going to plan to build them again. The planning houses stock is emptied by a building flow that feeds the houses under construction. That means planned stock is going to feed into a housing under construction stock, and the building flow is the planned houses divided by average lifetime. So, all seems to be a first order delay. Flow is stock divided by time, so it must be first order. Okay. The completion flow, that is whatever houses under construction, divided by the average time to build houses. Okay. Empties the houses of stock, houses under construction stock, and feeds to houses stock. Okay. So, we have 3 stocks: houses stock, planned houses stock, and houses under construction stock. So, planned houses become houses under construction, houses under construction become actual houses. Right. So, initially I plan more houses, then I construct them, then after it is being used, it is being demolished. All has to be connected through flows. The housing gap is computed as the difference in desired houses and current houses. The gap is adjusted over a period of 8 months. Average time to adjust gap is given as 8 months and is added to the planning flow. So, apart from just rebuilding existing houses, they also want to plan to build as many as a desired number of houses. So, build the ST model so as to start in dynamic equilibrium, and then there is another condition given: desired houses increases by 50,000 units in month 20. Okay. So, this is a very brief description. Let us see what happens when we housing stock dynamics. Oops, zoom. Okay. This is housing stock. We have 3 stocks and flows. As soon as you open it, it becomes quite apparent there is something wrong. Flows are not being connected to stocks, right. There is number of planned houses, there is no way it is going to reduce. The planning only will increase, there is nothing decreasing it, because as an houses getting constructed, then it has to decrease. So, it has become obvious that these flows has to be connected to the previous stock, and as soon as they complete, then houses under construction should also reduce. But just like please note that when I am clicking simulate, model is still simulating. Model does not care whether it is connected or not, model will still be valid. So, if you just say for example, if you click these and plot, they are getting some dynamics, something is happening, something is changing, which is fine, which is getting some large numbers, both positive as well as negative. But that is an obvious one. So, we can fix it first. So, let us clicking this delete and deleting this, clicking the rate. So, it is done. If you click equations, the rate equation has to be changed. You go to planned houses, it is already defined it, inflow minus outflow. So, all you have to do is click OK, click the second one, click OK, click third one, click OK. They all seem to be fine. Demolishing is this houses by average life, completing is houses by time to build houses, building is plan divided by average time, this is all fine, and whatever is getting demolished has to be replaced, plus wherever there is gap in houses that also has to be planned for. So, the planned equation includes replacement plus house gap by average time to respond to housing gap, which is also another first order delay. So, both are captured. Model seems now reasonably complete. So, let us just simulate. Let us look at the houses. This is the kind of dynamics we get. So, can we be sure this is okay? Is it okay? So, all changes was done is connected the flows to the stocks and we get this result. Okay. Again, as I told you, can practice it looking into videos. So, now the condition that was given was the model was supposed to start in dynamic equilibrium, right, and it was also given the desired houses was 5 million plus a step of 50,000 at a year at month 20. So, step function is given. So, that means for first 20 until time is 20, it should be flat, but here I am already seeing dynamics in time 0 or time 1 itself. That means model is not in dynamic equilibrium. So, what causes or not causes dynamic equilibrium? Dynamic equilibrium, the initial value should be the same, right. So, when desired houses is 50, desired houses initially is 5 million, houses also 5 million. So, the housing gap is 0, that is not adding anything to planning, right. Now, demolishing, the initial value will be 5 million divided by average house lifetime, which is given as, let me see here, average house lifetime is 100 years, that is since our time unit is in months, it is 1200 months, so which is okay. So, it is 5 million divided by 1200 is what is the demolishing rate, correct. So, then that much should be replaced every year, correct. So, the inflow here will be 5 million divided by 1200, that is how much? 5 million divided by 1200, $4116.67. Now, if that is the inflow, my outflow should be based on the average time it takes to build. The average time it takes to build is 3 months, or average time it goes from planning phase to starting construction phase. So, that much houses should be currently under a plan. So, that must be, so the planned houses stock should be how much value? The initial value. We go with little slow. The planned number of houses in pipeline should be inflow rate time the duration. The duration is given in the average time for planning to building multiplied by inflow rate. Inflow rate is 4166 times 3. $12500, right. Let us see that 25000. Let us consider changing it 12500. And time to build houses is 6. In steady state, if my inflow here is 41, what is it? 41666. So, this also has to be 41666, then this one also has to be 41666, 41666 into time to build houses is 6. So, 41666 into 6 is 25,000. So, housing under construction should be 25,000. This says 10,000, let us just do it 25,000, and this is 5 million, which is 5 million, which is fine. Now, let us simulate. Let us see the dynamics. It is starting in dynamic equilibrium. At least dynamic seems okay for now. This model is still not, but however these are constants inside it, right. So, you think about and come tomorrow to see how I can replace all these constants with equations. We do not want to put constants here. The problem with constant is now from say time to build houses, we knew it was 6. So, we multiplied directly or manually, right. Suppose how time to build houses increased to 7 months, I can't again go and check it. So, better way would be to see whether I can make it a equation. So, why don't you try that and we will continue that. Okay, thank you. I will stop here.